Let us take one more example on linearly dependent and independent of vectors. We have to examine for the linear dependence and independence of the following four vectors. x1 equal to 1 to 4, x2 is equal to 2 minus 1, 3, and x3 is equal to 0, 1, 2, x4 is equal to minus 3, 7, 2. So procedure is same. Let C1, C2, C3, C4 are scalars such that C1x1 plus C2x2 plus C3x3 plus C4x4 equal to 0. Let us give it equation number 1. Now we have to substitute all the values of x1, x2, x3, and x4. So x1 is 1, 2, 4. x2 is 2 minus 1, 3. x3 is 0, 1, 2. x4 is minus 3, 7, 2. If we open the bracket or if we multiply C1 with all the elements, we have C1, 2C1, 4C1, here 2C2, minus C2, 3C2. Similarly, here 0, C3, 2C3, and minus C4, 7C4, and 2C4 equal to 0. Now we will add all the corresponding element of this vectors. We have C1 plus 2C2 plus 0 minus 3C4, 2C1 minus C2 plus C3 plus 7C4, 4C1 plus 3C2 plus 2C3 plus 2C4 equal to 0, 0, 0. So these two vectors or these two matrices are equal. Therefore, their corresponding elements will be also same. So C1 plus 2C2 plus 0 minus 3C4 equal to 0. 2C1 minus C2 plus C3 plus 7C4 equal to 0. 4C1 plus 3C2 plus 2C3 plus 2C4 equal to 0. This is system of homogeneous linear equations. Ax equal to 0. It can be written as 1, 2, 0 minus 3, 2 minus 1, 1, 7, 4, 3, 2, 2, and this scalars are variables. These scalar variables are C1, C2, C3, C4, and the last column will be 0, 0, 0. This 0, 0, 0. Now we have to reduce this matrix to its echelon form. So with the help of this one, we have to make this and this 0. For this purpose, we apply the two row operations R2 minus 2R1 in R2 and R3 minus 4R1 in R3. Then the given matrix will be converted into this form. Let us just check its operation. We have to first apply this operation R2. R2 is 2 minus 1, 1, 7. We have to multiply this by 2. So 2 into 1 is 2. 2 to the 4. 2 into 0 is 0. 2 into minus 3 is minus 6. Minus, 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 plus. This is 0, minus 5, 1, and 13. Just look here. 0, minus 5, 1, and 13. This is similar. Similarly, from the third row, 4, 3, 2, 2, we have to subtract this R1 with multiplying by 3. So 3 1 is 3, 3 2 is 6, 0, minus 9. If we subtract it, this is minus 1. Oh, sorry, 4. We have to multiply by 4. 4, 3, 2, 2. 4 1 is 4, 4 2 is 8, 0, minus 12. Minus, 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 plus. This is 0, minus 5, 2, 14. Just look here. The last row is 0, minus 5, 2, 14. Now we come to A22. With the help of A22, we will make this 0. For this, we apply the operation R3 minus R2. So 5 minus 5 plus 5 is 0. 2 minus 1 is 1. 14 minus 13 is 1. After that, this matrix is converted to its equivalent form because 1 minus 5, 1 is the main diagonal, and below the main diagonal, all elements are 0. Therefore, this is the echelon form of the given matrix. Now, just look here. Here, there are 3 equations. Let us write down this in terms of equation. This is equation number 1 or 2, because 1 we have already given. Equation number 2, 3, and equation number 4. Since we have 4 variables and 3 equations, therefore, out of these 4 variables, the 1 variable is independent. Let us put C4 is equal to T in 4. Then we have C3 plus T equal to 0, or C3 is equal to minus T. Putting the values of C3 and C4 in equation number 3, we have minus 5C2 minus T, because C3 is minus T, and C4 is equal to T plus 13T equal to 0, which implies minus 5C2 plus minus T plus 13T plus 12T, which is equal to 0. If we transpose this, it will become my 5C2 is equal to minus 12T, and this minus minus will cancel. Therefore, C2 is equal to 12T divided by 5. Now, we substitute the value of C2, C3, and C4 in equation number 2. Equation number 2 is C1 plus 2C2 minus 3C4. If you put the value of C2 is 12T by 5, C4 is equal to T, then C1 plus 2 into 12 upon T, 12T upon 5 minus 3 into T. Multiply whole equation by 5. So 5C1, this 5 will cancel. 24T minus 15T equal to 0. 24T minus 15T is 90 equal to 0. So 5C1 is equal to minus 90, which gives us C1 is equal to minus 90 upon 5. Hence, we obtain all the values of C1, C2, C3, and C4, which all are not non-zeros. The values of C1, C2, C3, C4 are not 0, or we say that they are non-zero. Therefore, the given vectors are linearly dependent. Now, we want to find out the relation among the vectors. Putting the values of C1, C2, C3, C4 in equation number 1, we have C1x1 plus C2x2 plus C3x3 plus C4x4 equal to 0. Now C1 is equal to minus 90 upon 5, C2 is equal to 12T upon 5, C3 is equal to minus T, and C4 equal to T. These are the values of C1, C2, C3. If we multiply whole equation by 5, what will happen? Minus 9x1 and divide by, multiply whole equation by 5 by T, then minus 9x1 plus 12x2 minus 5x3 and plus 5x4. Let us transpose these two negative terms to the right-hand side and this positive terms to the left-hand side. Then we have 9x1 plus 5x3 equal to 12x2 plus 5x4. And this is the relation among the given vectors. Thank you.